Hello and welcome to the next video in my series on naming and formula writing. In this video I'd like to introduce or go through acid naming and acid formula writing. Acids, for our purposes, generally we're going to treat them as things that release hydrogen ions into water. Now those will ultimately produce hydronium ions, and I'll get into that a little bit later when we do acids and bases in class and pH and all that. But for now, for acid naming rules, these are basically hydrogen will be the first element that you're looking for. So when you see hydrogen as the first thing, we're going to assume that this compound will release that into solution, and that is what makes it an acid. Now again, there are a lot of definitions for acids and bases, and I'll get into more depth with that later. But for now, for the purposes of naming, when you see an H at the beginning, I'd like you to follow the acid naming rules. Now, as far as these rules, basically, since they all begin with H, all acids are going to begin with H, we kind of disregard that when it comes to the naming, and we base the name on the anion or second thing. Those anions generally are going to end in one of three ways. If you'll notice over here on the right side of the screen, they could end in "-ide". This would be any of the monatomic things. So for instance, if I have something like bromine and say sodium, we call this a bromide, so this is an IDE ending. Chlorine becomes chloride, sulfur becomes sulfide. So anytime you have a single element on the right side, that is an "-ide" ending, chloride or what have you. So what we're going to do is we're going to call that hydro, name of that anion, ic acid. So for instance, in this case, this would be hydrochloric, and then we're going to call that acid. So notice that I used hydro at the beginning kind of as a prefix, chloric acid. But the hydro only comes into play. A lot of my students try and put that in there all the time because they see these H's at the beginning, but that really only comes into play when this thing is an IDE ending, and certainly if it's a single element, that would apply as well. Another example of something like this might be H2S. This is sulfide, so this is hydrosulfuric acid. So that would be just another example. Now, ClO, and I did this a couple videos ago, we talked about naming of anions. ClO3 is a chlorate, so ClO is called a hypochlorite. So notice, endings that end in "-ite", we simply dump the "-ite" ending and it becomes us acid. So since this is hypochlorite, this is going to become hypochlor. And then what we do is we get rid of the "-ite" and we put us acid. So this is simply hypochlorous acid, and that's how you would name that one. HClO3, I mentioned a second ago, that's your chlorate ion. 8s become ic acid. So basically this is chlorate, so I'm going to keep the chlor, CHLOR, I'm sorry, and then instead of 8, I put ic acid right on the ending. So the please don't get distracted by the hypo here. That's not like hydro, and there's a difference there. This just happens to be the name. If you look at a list of those oxyanions that I've talked about, there's a thing called a hypochlorite ion, and that's what that is, and it's caused by the fact that you've removed 2 oxygens from this guy here, and that's what this turns into. Now, one way to remember this, I always tell my students, sometimes this can be a little bit tricky. I always just a mnemonic, and I've heard a lot of teachers mention this over the years. I ate something and I feel kind of icky, or I ate it and I felt ick, or something along those lines. Sometimes helps folks remember that. This one would be "-ite" to us. So think of tonsillitis, tendinitis, appendicitis. Think of "-ite" to us acid, and sometimes that will help you remember this as well. Now, let's go in the opposite direction, and let's go from the name to the formula. Chlorous acid. Well, us acid, what I need to do is replace the us acid with "-ite". So this is going to be based on the chlorite ion. Well, the chlorite ion, if chlorate is ClO3 with a -1 charge, chlorite means I'm removing 1 oxygen, so that's going to be ClO2. When I write the formula, the number of H's, since H's are always +1, is really, it's the same as the charge here. So since this is -1, I only need 1 H in front, so this is going to be HClO2. Perchloric acid, again, ic acid, I'm going to get rid of the ic acid and replace it with an 8. Perchlorate, well, if ClO3 is chlorate, perchlorate is ClO4 with a -1 charge, so I again only need one H in front because of that charge, and it's going to be Cl O4. Now let me give you an example where you'd have more than one H. If I had sulfuric acid, okay, that is going to be based on the sulfurate ion, which is SO4. That has a -2 charge, so that means I'm going to need two H's. So that's going to be H2. I'm sorry about that. H2SO4. And again, the two H's are coming from the fact that this has a -2 charge. So that's how you name acids, and again, the way you recognize it is you're always going to just have these H's at the beginning. Now in the next video, what I'm going to do is mix all of these up and try and help you know when to use which naming scheme, either the ionic, covalent, or the acid naming. So I hope you tune in for that. Talk to you later.